Hi everybody, today we are starting day one, first algebra lesson. As far as notes go, take notes depending on how you think you learn best. If you want to just listen and watch me go through these notes and not write anything down, that is okay. If you do work better writing something down, if you want to print out the document that I posted that goes along with these notes, that is fine. If you want to have a notebook next to you and taking notes, that is also fine. All based off of what you think you need to do to make sure you learn best, okay? So I'm not requiring you to write anything down. You can if you want, if it's easier for you. If you prefer to just listen and pay attention and take it in, that is okay. This video is going to get posted on Google Classroom. You're always going to be able to access it. It's always going to be there. So if you forget something or you want to reference it back, it's going to be there for you. Okay, so our first unit is about the real number system. So we're going to be talking about defining numbers in the number system, classifying and graphing numbers, and then writing what is known as a rational number as fractions. Okay. So if we go ahead, here's our first section, talking about the real number system. Okay, so everything that you've done so far, we've just kind of had all of the numbers and we worked with them. You talked about them, positives, negatives, fractions, but you never actually worked with classifying what they were. So our whole entire number system that encompasses every number you can think of, that is called your real numbers. So real numbers, again, everything that you can think of. So as we talk about these, we're going to condense them down smaller and smaller and smaller and smaller and smaller, making our groups smaller. So real numbers is my largest group, contains everything. Then I get to rational numbers. Rational numbers are numbers that can be written as fractions. So numbers that can turn into fractions. Okay, so that includes whole numbers, that includes negative numbers, decimals, fractions, square roots, anything that you can rewrite as a fraction. Okay, so if we go through some examples, 3 is a rational number. How can I write 3 as a fraction? Well, what can I put 3 above to make it look like a fraction? 3 is the same thing as 3 divided by 1, so there's my fraction. Fractions are already written as fractions, so those are rational numbers. So 3/4. Improper fractions, 4/3. Mixed fractions, 1/2. Decimals, 0.5. Ask yourself, well, if I'm looking at a decimal, do I know its fraction counterpart? So can I write 0.5 as a fraction? I sure can. That's the same as 1/2. Square roots are rational numbers. We're going to save that for day 2, so we're not going to get into any of that here. But so I have my real numbers, which are everything, and then I split my real numbers into 2 groups. I have rational numbers and I have irrational numbers. Rational numbers we're going to talk about first. That's everything that can turn into a fraction. Negative numbers, so I have -1/4, -4, because remember I can always write a whole number as a fraction by putting it over 1. Okay. Then I'm going to take that group, make it a little bit smaller. So I have my set of rational numbers. If I condense it a little bit, I have my set of integers. Integers are just positive negative numbers. So once I get into the integer world, I'm ignoring and eliminating all of the fractions and decimals. So integers are positive and negatives. With, that's an abbreviation for with, it's a W with a slash through it. So positives and negatives with no fraction or decimal. Okay. So again, real numbers, everything. Rational numbers are everything that you can write as a fraction. Integers, your positives and your negatives, not including any fractions or decimals. So now we're going to make that group a little bit smaller and we have the set of whole numbers. So can you think about what I can do with a set of numbers to condense them a little bit? Your whole numbers are positive numbers, including 0. Okay? So it's your set of positive numbers with 0 included. So we're specifying that because 0 doesn't count as a positive or a negative number. So your set of whole numbers is everything that's positive, including the 0. So keep in mind, if you're looking at this Venn diagram, since my circle with whole numbers is inside my set of integers, if I have a whole number, it's also an integer. If I have an integer, it's also a rational number. Okay. However, since rational numbers isn't inside of this whole number circle, all rational numbers don't necessarily mean that they are whole numbers. You see how that works? So I have my circle inside of different things, so they're all included, but it doesn't work from the outside in. Whole numbers are integers, are rational numbers, but it's not going the same way. The next set you have, it's something that we're not going to talk too much about. We don't really include it, but it's your set of natural numbers. Set of natural numbers now are just your positive numbers, not 0. So we're taking that set and making it a little bit smaller by taking the 0 out. So my natural numbers are 1 and beyond. Then I make it a little bit bigger, my set of whole numbers by adding the 0, a little bit bigger, my set of integers by adding the negatives, and then a little bit bigger, my set of rational numbers adding the fractions. That moves us now into talking about irrational numbers. So if a rational number is something that can be written as a fraction, that also means that irrational numbers are numbers that can't be written as fractions. Okay, so what that means, that if I'm looking at decimals, I know it's an irrational number if it's a decimal that does not end or repeat. Okay. Because we have our common decimals that end would be 0.5, 0.75, 1.35. Anything that terminates is a rational number. You can write it as a fraction. Something that doesn't terminate and it just keeps going on and on and on and on and on and on and on in this crazy, crazy, crazy pattern that never repeats any numbers, that's your irrational number. Okay? Your most common irrational number, if you might know, is the number pi, right? Because if you estimate 3.1415 and it's going to keep going on and on and on and on and on, and you're never going to hit a number here that repeats, and you're never going to have an end to it. Okay, so those are your irrational numbers. They're all your really funky decimals that never end or repeat. So that's your classification. Natural numbers turn into whole numbers by adding 0, turn into integers by adding negatives, turn into rational numbers by adding fractions. Okay. Moving on. Example 1, we're going to take all of these numbers and write what groups they belong to. So again, we want to specify that if I'm saying that something is in this center group of a natural number, that means it belongs to everything that this circle is inside of. So if it's a natural number, it's also a whole number, it's also an integer, it's also a rational number. It doesn't go the other way. Okay? So if we start, here I have a mixed number. Anytime I see something that's a fraction, that's going to tell me, well, it's a fraction. It already meets my condition of rational numbers because rational numbers can be written as fractions. So I'm going to start there. So I know it's rational. I'm just going to write an R because I'm going to run out of space. Okay, I know it's rational, but now I have to kind of condense it further and further and further. So my set of integers eliminates all of my fractions. So this isn't anything more than just a rational number, right? All of those inside sets don't include any fractions. So I'm not going to write that. So it's just my rational number. Now I have -5. Okay, so now let's start working from the inside out of our diagram. It might make it a little bit easier. So -5, it's not a positive number. It's not a positive number including 0. It is a negative number. So that first set that -5 belongs to is my set of integers. Once I find that first set, it then belongs to everything outside of it. So since my integer circle is inside of my rational number box, it's also a rational number. Now I have -4.4. It's not a positive number. It's not a positive number including 0. Integers specifically say positive numbers with no fractions or decimals. So the fact that this has a decimal here makes it not an integer. So again, just like my first option here, anytime I have an actual fraction written or a decimal, all that it is my rational number. Now I have 0. Is 0 a positive number not including 0? Well, no, 0's in it. So that makes it my set of whole numbers, okay? So again, I figured out that it's a whole number, so then it also belongs to everything else. Whole numbers are inside of integers, are inside of rational numbers. 0.31, that's just my decimal. It's a terminating decimal, it ends, so just a rational number. Same thing for the rest. This is just a rational number because it's another decimal. 80%, we didn't talk about anything being percents, but percents are always out of 100. So this is really just 80 out of 100. So that's just a fraction, right? It's 8/10. So that means it's my rational number. And then 0.3 repeating is still a rational number. Remember that irrational numbers are just numbers that never end or repeat. This 3 is going to go on forever. So it's not ending, however, it is repeating. And if you think about it, what is 0.3 repeating as a fraction? That's the same thing as 1/3. So anytime you can think of what that fraction is going to be, that's your rational number. Moving on to example 2. So here we have a bunch of rational numbers. I want to graph them, and then I want to go ahead and put them in order from smallest to largest. So I have a lot of fractions. What's good about example A is that all of my denominators are the same size. So anytime you see this where all your denominators are the same size, you really just have to compare the top numbers, because if they're all out of thirds, then you're just looking at your top numbers, okay? So I have some negative numbers and I have some positive numbers. I have some improper fractions. First thing we want to do is go ahead and figure out your scale. So I'm counting by thirds. So let's put 0 in the middle because I know I have some positive numbers and some negative numbers. So I'm going to count 1/3, 2/3, 3/3, 4/3, 5/3, and then I have -1/3, -2/3, -3/3, and -4/3. So now if we go ahead and plot them, 5/3, then I have -4/3, 2/3, and -1/3. So now, looking at my graph, I can put them in order from smallest to highest, because if you're just looking at this list, sometimes you might be getting confused with your negative numbers, especially if we're working with fractions. So what's my smallest number? -4/3 is smaller than -1/3, which is smaller than 2/3, which is smaller than 5/3. Okay. Part B is a little bit more complex because they're written in different forms. I have percentages, I have decimals, negative numbers, repeating decimals, mixed numbers. In order to compare something like this, you want them all to be in the same form. Okay, so if I want them all to be in the same form, I like to compare things as fractions. Okay, so we're going to work like that. I don't, however, want to mix up mixed fractions and improper fractions. So I liked how easy this one was, right? I made all of the denominators the same number, and then I could just go through and compare them. That was pretty easy. Thinking about it now, though, if I have this mixed number, I'm going to keep that as it is. I'm going to write this as a fraction and this, and then I would have to go through and find that common denominator. That seems like a lot. So if I don't want to work with fractions, what's the next easiest type of number to compare? Or I already have 2 that are written as decimals. So what if I go ahead and just convert these also to decimals and see what we get? Okay, so I have 6 and 4/5. So I have 6. If you don't remember what 4/5 is as a decimal, think about this. Okay, so out of a whole, take a whole and divide it into 5 parts. So a whole is 100. If you take 100 and divide it into 5 parts, each part is worth 20. So if I have 4 of those 20s, I have 80. So 4/5 means that it's 6.8, right? If you want to check in your calculator, 4 divided by 5 gives you 0.8. And I'm going to keep that whole number out front. And then I have negative 5.5 that's going to stay there, 6.3 repeating. And now I want to write my percent. So a couple different options. If you remember how to go from a percent to a fraction, percents are always out of 100. So I have 6 over 100. You can keep reducing that if you want. You can divide it out. Or if you can remember 6, you just move your decimal 2 spaces. So now I have 0.06. So I'm going to take a look at all of my numbers. I want to figure out my scale. I have this really, really, really little number, and then I have some bigger numbers here, both positive and negative. So I have to make sure I can make it all the way up to positive 6 and all the way to negative 5. So I'm going to go ahead and put 0 in the middle since I have to have positives and negatives. I'm going to go ahead and count by 2s. So I have 2, 4, 6, 8, 10. And then I have negative 2, negative 4, negative 6, negative 10. Now I'm going to go ahead and plot. So I have 6.0 is just going to go, oh, why did that write as 0? That was supposed to be 6.8. So 6.8, to make my number line even a little bit easier, I'm going to go ahead and write little tick marks to show the ones places. Because if I'm going ahead and writing 6.8, I want to make sure I put it somewhere down here. My next number is negative 5.5. So I have negative 4, negative 5.5, 6.3, and then 0.6 is almost right there. So now if I go ahead and write them in order, keep in mind that whenever you're rewriting and answering these questions, you want to take these and you want them to be written in their original form. So what was my smallest number? My smallest number was negative 5.5. So I can write it like that, negative 5.5. Then I came all the way to 0.06, which was 6%. So I'm going to make sure I'm writing it as 6%. And then I came over here and hit 6.3 repeating, which that form stays the same. And then I'm going to come up here and hit my last number, which was 6.8, but we're going to keep that as 6.5. So there's your number lines, how to use them to order your rational numbers. And then if we move on to our final example for the day, we have these rational decimals, and we're going to go ahead and figure out how to write these decimals as fractions. Okay? So we're going to take a break because these two examples were a lot. This gets a little bit more involved, so I'm going to stop the video here. You can take a stretch break, you can take a little mind break, and then go ahead and click on the second video to view how to do example 3. See you later, guys.